In this video, we will consider how the sine and cosine functions can help us make sense of circular motion in an applied context. In order to help us get to this goal, let's revisit some ideas we have recently discussed in class. Consider this circle that has a radius that is 4 units long. Also, consider the point on the circle as a point that began as the point 4, 0 at the 3 o'clock position and has rotated to its current location. We have said that we can describe the current location of the point by describing its distance above the horizontal diameter, which is the blue line, and the point's distance to the right of the vertical diameter, which is the red line. Also, in previous sections, we were introduced to the sine and cosine functions as functions that input the amount of rotation from the 3 o'clock position, represented by theta, and functions that output the number of radius lengths above the horizontal diameter for the sine function, and the number of radius lengths to the right of the vertical diameter, the cosine function, that the point is. So, if we want to know the bug's specific location in the plane, then the x value will be 4 times as large as the cosine of theta, and the y value will be 4 times as large as sine of theta. With this understanding of the sine and cosine functions at our disposal, let's consider Module 7, Investigation 5, questions 2, 3, and 4. Pay close attention to the quantities expressed in these problems, and remember to focus on the fact that the sine and cosine functions accept the angle of rotation as the input quantity, and that they both output distances measured in units of how many radius lengths. Or you could also think of them as units of how much of a radius length. So, for question 2, you are asked to write a function that inputs the amount of rotation and outputs the vertical distance above the location of Jose's hand. Questions 3 and 4 take these ideas a step further. Part A asks you to input the number of seconds Jose has been twirling the ball and to output a measure of the amount of rotation of the ball in radians. In question 3, the ball is traveling at 1 radian per second, but in question 4, the ball is traveling at 2 radians per second. To determine the relationship in part A of these two questions, it may be necessary for you to consider specific values for t and then determine what the corresponding values for theta would be. After you've done this for a few different pairs of values, then you could generalize your observation for any value of t and any value of theta. Moving on to part B in questions 3 and 4, you are asked to determine a function that will output the vertical distance above the horizontal, but that inputs the number of seconds that the ball has been twirling. Now, because the sine and cosine functions only accept angles of rotation as an input, we see that there must be some two-step process as part of the answer to question 3. So think carefully about your answers for questions 3 and 4 for all parts here, and show your work. Now, question 5 asks you to go through the same process that you did in questions 3 and 4, except now the ball is traveling at 0.5 radians per second, or a half of a radian per second. Complete all parts of questions 2, 3, 4, and 5, and submit your answers using your instructor's preferred method by the time and date that your instructor has identified.